I'm very glad to share some new novel techniques and methodology in various fields in science and arts and cultures on an interdisciplinary manner. So the content of my talk concerns what is STEMAC and the applications, and particular applications that I have made and I have developed this field amongst the various disciplines, which is a bridge of natural sciences and humanities. In the European Academy of Sciences, we have created an expert group, an initiative that I have proposed, and it concerns the science, technology, engineering, mathematics in arts and cultures. And our aim is to collaborate with institutions from Europe, involving students, of course, and colleagues, and to foster this field one step forward. We're talking about a holistic approach to current developments in education, research, and innovation. This trio is the most important, target of STEMAC. Initially, STEM, by some scholars, is called STEM. STEM because the A is the arts, the acronym. Science, technology, engineering, arts, and mathematics. I think that it is missing the culture, cultural heritage and culture in general. So we have introduced this STEMAC, which stands for Science, Technology, Engineering, Mathematics, and Arts. And it is a bridge, as I said, between humanities and natural sciences. The definition of the terms arts, we know, but just to remind you, musical arts and sounds, performing arts, social arts, language arts, visual arts, and culture encompasses tangible and intangible. Tangible is material culture, cultural property, and intangible, for example, religion, dance, music, literature, and the exact sciences that all of us know what involves and what encompasses the exact sciences. There is a particular focus for STEMAC in the past heritage, in cultural heritage. In the European Academy of Sciences and Arts, an expert group, as I said, was formed, science, technology, engineering, mathematics in arts and culture, and this task force of the subject comprises of active members of our academy, working on this interdisciplinary fields, because our academy in Salzburg has 7 scientific classes, which involves, almost all the field subjects, in science, technology. So on an interdisciplinary way, the STEM that brings together arts and cultures, this may involve also other classes out of the 7 in our academy. That's why I said in the beginning, this is interdisciplinary and holistic. This is an official roadmap for policy for STEM in arts and cultures, and we believe that we need more clarification about this interdisciplinarity, and we have already published a policy paper in our official journal of the Academy, which is called Proceedings of the European Academy of Science and Arts. So our motto in the Academy is STEM in education and society, research and innovation, and to develop transnational and interlaboratory cooperation on this interdisciplinary field. And this involves projects, funded projects, probably master thesis, PhD thesis, policy papers. The 2023 in Athens was the one first meeting and several to follow that invited experts from Greece and members of EASA. EASA is the European Academy, have had a brainstorming on education and research related to STEMAC. The policy paper, as I said before, has been already online, free download in our official journal of EASA. You can see this link here, so you can download, this policy paper. In the future, we plan within the year to formulate a European network for STEMAC and a special volume on this subject. Here you can see, an extract on the right down here side of the paper that has been already published and gives all the, the information, details about this effort. Now, indeed, the EASA, European Academy, promotes the STEMAC in arts and cultures for education, research, and innovation. We have a target for collaboration and establishing partnerships that can bridge the gap between these fields, curriculum development in higher education or lyceum, with the hands-on activities that engage the learning of students, real-world problems solving, and allow them to explore and experiment with different technologies, creating opportunities for experiential learning, integration of technology, 3D scanning or printing, for example. Of course, we need teacher training always in a frequent, times, because the field, as all the fields in technology, they develop, they grow in a very, very incredibly fast way. Evaluation and feedback. Regular evaluation and feedback can help improve the quality of the subject, providing access to resources and community engagement. That means through public events, workshops, exhibitions, can raise awareness of the benefits of STEMAC. Some concrete ideas for the 3 educational levels involve innovative teaching methods, interdisciplinary subjects, like biomolecular archaeology, for example, and develop critical thinking and interdisciplinarity from within the merging of education, research, and innovation. As you can see here on the right, there is a pyramid which has a base, has learning outcomes and learning and tools and outcome on the right. So science, technology, engineering, mathematics, informatics, they use tools to engage, explore, explain, elaborate, evaluate, enjoy, and the outcomes, of course, is finally the education and is the transdisciplinary, integrative, multidisciplinary education, which, after all, studies the cultural heritage and gives to STEM, science, technology, engineering, mathematics, an holistic approach to all these subjects. Some examples of using holistic approaches, of STEMAC involves the cyber archaeometry, the integration into education, research, innovation, and case studies. I can mention 2 of them: artificial intelligence and archaeology, data analysis, 3D modeling, facial reconstruction, of ancient, people, age estimation of dental images, digital automation. There are so many sub-disciplines and sub-specializations, that is a plethora of choices for a student to follow a specific speciality, which would be useful for the market and for himself. A second example is the digital automation in archaeology, like using GIS, of course, remote sensing technologies for example, discovering archaeological sites which are buried, digital recording and documentation, database management system, etc. As you know, as you see there, I mentioned just main ones, main examples that how STEM in arts and cultures can break down in several sub-disciplines and involving content and material. After all, what the basis of all this growth and development is the motivation, of course. Okay. A vision and sustainability. A vision stability is to integrate the fields of STEMAC in a way that fosters creativity, innovation, and critical thinking. We try to do that in our academy. Also, new technologies, tools, and techniques can be applied. For example, can help CCI, which is the cultural creative industries, which have a sustainable economic benefit, after all, in the cultural heritage. Arts and cultural sectors can offer new avenues for scientists, engineers, and mathematicians to explore and express their work in a more accessible, engaging way in education, research, innovation, and to promote diversity and inclusivity. After all, this holistic strategy involves partnerships, teamwork, and curriculum development, teaching, training, experiential learning, and regular evaluation of feedback. In our academy, we foster this interdisciplinarity with STEMAC, and that promotes also the Sustainable Development Goals 17, as have been set, and promoted by United Nations, SDG, as well as the much needed understanding between people, because peace, much wanted every time and how rather in our era, and mutual understanding presuppose comprehension. And STEM in arts and cultures from various countries, okay, can achieve this vision. So arts and cultures with STEM, we believe that link the work and link the worlds. Some of my major current projects, archaeometry and STEMAC, archaeometry, archaeo measurement. It's a Greek word, but it has been used, and coined back in the 50s by Oxford University. It is the measurement of the past, the measurement of monuments and artifacts in the past in order to decipher various variables and to extract information regarding dating, temperatures, techniques, provenance, and so many other things. My major currently running projects, which belong to this STEM, specialty, concerns ancient archaeometallurgy and corrosion characterization, surface luminescence dating, how to date monuments or rock art, a multidisciplinary methodology in an excavated site of late bronze near Delphi in Greece, new approaches, dating approaches using science, technology, mathematics in obsidian hydration dating, and fractals and complexity in art and archaeology. The advanced electron microscopy has been used, but together with other advanced, techniques of synchrotron, to study the history and conservation of ancient Chinese heritage metal finds. Here we have made a recent application of nano microcrystals revealed from a Tang dynasty gilded bronze using advanced TEM-SEM, transmission electron microscopy and scanning electron microscopy, and synchrotron methods. Tang Dynasty is the 7th to 9th century AD, one very great period for China, big growth, and especially in developing and manufacturing and using, gold and gilded bronze materials. The question was how ancient Chinese bronze metals at Tang Dynasty were made and which changes have experienced. Or other question, what is the role of corrosion and strategies to conserve them? So we use non-invasive techniques, analysis in nanoscale, which is such as X-ray, which is particularly useful because archaeologists do not give us permit to get sample, to take out, to extract, to cut pieces, because they are very important cultural assets. So mostly we use either minute samples of millimeter, 2 millimeters, size, or non-destructive ones like X-rays, and we have determined the weathering processes that affect the archaeological artifact. It is important to know this information because it helps to conserve, to restore the material and to prevent the loss of the archaeological record. Understanding and preventing the corrosion in Chinese and Bronze Age is a major concern since their conservation is of utmost importance to preserve their material history. And in our project, we used, as you can see at the end, very modern and highly advanced instrumentation. It was, after all, this project, a combined project of many laboratories and with our Chinese archaeologists who provided the material. Another important aspect in archaeological research is to date ancient monuments. The monuments are inorganic materials. The organic materials are dated by carbon-14. The anorganic there is not any other method apart from the luminescence dating. And this is one of my contributions back in 1994 that I developed, a novel methodology how to date ancient structures which have been made by blocks of stone, marble, granite, basalt, and the rationale, the technique, the idea is based on the solar radiation that erases on the surface of the stone block before it is put, in the wall, erases the luminescence from stone surfaces, and that means it sets the zero time. Being covered by another slab, the luminescence in the crystals start to develop, to increase from zero until today, provided that the old surface, when it was made, this block as part of the building, it was always kept in dark, that means covered by an upper block. Once this upper block is removed, shifted by various reasons, repairing, earthquake, or demolishing, etc., then the time starts from this time of the event until today. So that simple as it looks idea, finally it helped to date various materials, monuments from Egypt, from Germany, from Greece, from many megalithic structures. Another extension of this dating of luminescence involves the rock art. You can see here some cupulas curved in a rock surface in India, and we date the exfoliation of stone pieces that fall, you know, in the from the wall for various reasons, temperature, you know, weathering, etc. They fall into the ground, and then they are covered by sediment. Once we find the sediment and we identify the cupule or the surface, we can find the time this piece of exfoliated stone piece fell on the ground, the timing. So this is one post-adequem dating, the minimum age that we give about when this cupulus and rock art was made. So, but we have developed, or I have developed also another way of dating this rock art, provided that we get a core from the surface inside, 3 to 3 centimeters about, a borehole, you know, with a diamond, and take out, you know, this core from the surface, which includes surface and the inner part of the rock. And then we make radiation measurements per slice of this core. And we make some family curves, which family curves may give us a clue when the curving of the rock art by prehistorian was made. So this is an advanced level in dating rock art. We have applied this technique, of course, in various parts in India, in Greece, and for example, here are some plots of luminescence as a function of depth. This is a characteristic, you know, piece that were given to us in order to date, you know, when it was fallen into the ground, and we have found 2 ages, 70 around 1000 BP and 46,000 years BP, which means 2 times the rock was fallen 70,000 years. The rock art was made before 70,000 years, and then due to the disturbance of the sediments, it was exposed to light and then covered again by sediments. And we found that this event, the second event, happened 40,000 years before present. Another interesting application which involves a methodological multidisciplinary tools concerns a site which it is called Castruli, is a little castle, you know, in English, which is a late Bronze Age site around near Delphi. We have used many methods from science and technology in order to find various information about that. Like this site belongs to late Bronze, 1300 to 1100 BC. 1100 BC is the final destruction of the Mycenaean civilization, but at the same time, the Anatolian and Near East were destroyed. The hypothesis and some evidence they have, scientists, scholars, they think that that was due to a sequence of strong earthquakes in the Anatolian seismic arc, and also increased drought, which made people, you know, to uprise and then to move away, not cultivations, not food, etc., etc. So some finds we have unearthed small gold foils, all some beads, some figurines, and various types of pots. This is the round, you know, settlement, which is fortified, and all the houses are inside here. We have excavated 2-3 sites only, 2-3 points here, you know, and we have found, you know, a tomb with 16 individuals and a lot of ceramic stuff. The question here was first to use instrumentation in order to identify the origin of the clay that ceramics were made. and also to solve the question where these potteries and sherds and pieces of fragments of ceramics coming from abroad, from other sites abroad, in the periphery, or were made by the same people. That is a very good question, and also what was the technology of using the ceramics? What are the recipes, and what is the firing temperature? So interesting questions that they study the past. We study the past societies. We found temperature 850, 850 to 950, and 900 to 1100 degrees centigrade. It was the firing temperatures of various ceramics that were used for different purposes. We have also identified clay sources in the periphery of the settlement, and we made simulated ceramics from these clays and mixing as well these clays, and we produced somehow pottery, like fire pottery at different temperatures. So making this experimental simulation project, we compared the results with the ceramics that were found in the site. And here is a typical dendrogram cluster analysis to see if matches the clay of the real ceramics with the simulated ones, which are made by clays derived from the area. We used statistics, okay, hierarchical cluster analysis, several linkages, descriptive statistics, biplots, principal component analysis, all these things. And we have seen that hundreds of ceramic artifacts were made by local clays, mixing the local clays. It's very important. 8 local clays we have identified, and also we found that analyzing, comparing all the ceramics, simulated ones from clays and the real ones found in situ, using 15 major and minor trace elements in employing statistics. And we found that it was 90% from local clay and around 10% coming from other sites. These are some pictures of the images of the top of the ceramics, of the 45 walls and the top inside, that we took also some sample of stone in order to date when the tube was constructed by applying the surface luminescence dating. Also, we applied radiocarbon because we found carbon, we found seeds, which have carbon, and we compared the radiocarbon dating with the luminescence dating. You can see, for example, here on the right, the radiocarbon dating as from 2500 to 0, and how they span, within an age. They start from around, within the error, 1400, 1500 BC. Most of the time, most of them were here around 1200, but you can see that the site, although it was destroyed around 1100, still after some time soon, 11th century, 1900 BC, people came and re-inhabited the site until, archaic, classical and Hellenistic times. Now, the geophysical prospection, also using electrical and radar, GPR, and magnetic measurements, revealed buried structures beneath the ground. That was a guide for us in order to make the excavations. We didn't excavate by chance, okay? Also, we have made an investigation on geoarchaeological dimension to explore if there was in a lake or marsh nearby to this settlement. There is a flat area that even today local people tell us that for the last 100 years, every winter that floods, and it is very bad for their their cultivation. So that gave us the idea probably that was once upon a time a lake. So we made various geophysical approaches and using GIS as well, measuring the slopes of the area around Castruli. We use electrical resistivity tomography to see the resistivity and how loose, or hard rock, are the sediments. And we find this is the lake, one winter, and here is how the settlement looks from above, aerial. Here is nearby Delphi, Greece, and we made in this area the two traverses of electrical resistivity tomography, and here is the result of the tomography. And indeed, we have this is the settlement of this hillock around 150 above the ground, the plain, and here is the two traverses in order to measure the resistivity beneath the ground. So, for example, the mauve color means rock, the green and yellow is very loose sediment, not rock. So making analysis of boreholes, you can see here, and making a measurement of chemical elements along these boreholes from surface down to 6 meters, and making C14 dating and luminescence dating of these various horizons, soil horizons in this course, we have found that as a function of depth, around 10 meters, the dating of the sediment was around 3,000 years before present, which is the same time that Castruli was a site settlement with people there, etc. So indeed, we have around 40 meters depth with water, and eventually, due to the sedimentation rate, this and the efforts of the people to drain, this lake, finally it was made, it was filled by sediments, and today it's a plain, but two holes, natural holes, which were also engineered by ancient people in order to drain the water, are apparent there. So this is another evidence that indeed they made some hydraulic efforts, those people, in order to drain the lake, which we have already discovered and dated very accurate. We used cyber archaeology in this project, involving total stations, balloon aerial photography, drones, etc., 3D modeling. It was a very sophisticated, combined techniques in order to make an accurate excavation and recording and analysis of all data found there, which means big data. So we have to manage big data. Here you can see clearer on the right the settlement. This route and a route with many the green bushes is the fortified wall of the settlement. Some conservation in 3D of the found objects, hydrias, for water, for keeping wine, for drinking, wine as well, kylix, and other aspects of how people are going to working in situ, and how our conservationists, try to rebuild, and to restore these finds. Okay. Also, we made some DNA analysis, which has to do with genetic, past of these people, and indeed we found excellent results from the individuals in the top. Castruli people were relatives with all Mycenaean Greeks, so they were Mycenaeans, like Greeks today. One adult in one tube has this exactly the same DNA with someone from Aburias in Spain, had same ancestry from Castruli people. We know from history that in the second colonization, Greeks went to the Marseille in Nice in France and Aburias as it's called in Spain, and they made colonies. So we prove, verify, confirm this historical event by asking DNA. And also the diet in Castruli people were marine vegetables, goats and sheep, cattle, which, and also they had very good teeth conditions, Mediterranean food, you see. Another subject which I work is fractal, and amazing, simple, but yet infinitely complex. These are, as you know, fractal dimensions are the measure of complexity that indicates the degree to which the objects fill the available space. It is a mathematical shape that it is infinitely complex. Is a pattern that repeats forever, and every part of the fractal, regardless of how zoom in or zoom out, it looks very similar like the original one. We use these techniques, my scientists, and in my case, I have used in archaeology, in cultural heritage. I'm not going to get into the detail of of more fractal analysis and how it works. You can see it in various books. But example of fractal anisotropy, for example, index shows different textural patterns. So we can classify patterns based on these fractal anisotropy properties. Okay. Another one is, for example, case when we use the fractal anisotropy index to quantify directional complexity in neurosciences and biomedicine. What means that? For example, we have two images here. One on left is collagen, and the second is gelatin. The number, the dimension, which is not integer, is fractal. 1.3, for example, 2.35. The fractal anisotropy index ranges from 0, which is minimum, to 1, which is maximum. 0, what means? Isotropic structure, no directionality. 1, what means? Highly anisotropic, strong directional complexity. So anything between 0 and 1 classifies, our image. So it's a very efficient, very good tool, to classify and to group various materials only by analyzing the image analysis, pattern recognition using fractal or complexity measures instead of applying instrumentation, which is expensive. One has to have funds in order to get in the laboratory, needs calibration, needs maintenance, So it's a cheap way and very coming up, subject of using image analysis through fractals, which fractals also are many algorithms, and continuously they increase. Increase as number of fractals, algorithms, but depending from the problem that one wants to solve. Can we apply fractal anisotropy index in archaeological science? Yes, we can apply to analyze anisotropy of micro and macro photographs, for example, in archaeomaterials, in marbles, in ceramics. Okay, we can detect crystal orientation, tool marks, or post-depositional alterations. Another usefulness of fractal, and especially the fractal fragmentation index, FFI, is to quantify multi-scale the effects of the deforestation, the degree of deforestation. Okay, which implies destruction or reduction of forest compactness, which the consequences is the impacts of an ecosystem and biodiversity. I have given some pictures here, some images, dark, black, etc. Just remember that the from zero, here is from 0002, 0003 on the right, 0206. Okay, from 0.06 approaches the 1. The first one here, which is more dark, is towards 0. So from 0 is highly fragmented or very small objects. The last two, images, spots with 1 to 4 white pixel size, or all size are black. But if we go towards 1, this is perfectly compact Euclidean shape. All pixels are white. Higher values indicate compactness. Lower values indicate fragmentation. Can we apply this to archaeological science? Of course. We can apply for amphora shapes, obsidian thin section images when the water enters obsidian, ceramic thin sections. So when we want an image to be analyzed and to find various aspects, variables of this image, which image probably represents, a phenomenon, geological, physical phenomenon, then the various indices, fractal indices, help very much in order to identify and classify such objects. Some examples we have done with fractals in art, and using, especially the Kolmogorov compression complexity, we have analyzed 1,200 Byzantine icons painted between 13th and 16th century from Greece, Russia, and Romania, the Orthodox, church, the Orthodox religion, and the Orthodox painters, through the Kolmogorov algorithmic information theory. And we concluded that the normalized Kolmogorov complexity methodology indeed offers the capability to differentiate the icons if they come from one school or painting school or the other school. Here, for example, you can see examples. The 3 blue bars here represent different dimensions of Kolmogorov, different numbers, different heights, belonging to different schools. Greece is here, in the Romania in the middle, and Russia on the right. So we have identified the one Byzantine icon, when it is presented to us, and we make a very clear and high resolution photography, then we can compare with the database, and we can say, this one is of the Russian school or Romanian school. Okay. Other icons that from Kolmogorov complexity identifies painting school, you can see the 3 bars, how well are distinguished between the different schools. Okay. Also the RGB is the red, green, blue. Okay. And Pilkowski fractal can apply to the manuscripts. That is a 1819 secret initiation manuscript of Fellows of Greek Revolution. Image processing of scribal and ink identification and paper. So we have identified different inks in this manuscript, different papers, and how many scribers as well. Here, for example, you can see we have analyzed the 5 lines analysis per page. The pages were 20. So you can see the Minkowski fractal is not, the fractal dimension is not the same. There are different differences, which means some pages were written by different scribe author. Okay, this is all lines in one page fractal analysis, and the Minkowski dimension for each single geometrical word in the manuscript in all pages. We can identify again the number of scribes, because each scribe writes has his own style in writing one word. So if we take the same word in all manuscripts, in all the pages, the same word, then we can see if differences which imply different scribes.
Dear Professor, 45 minutes allocated are over. How long you are going to?
I'm finishing a while.
Okay, thank you.
So another thing that we have done is using fractal obsidian studies, which is a work in progress. For first time, we apply a novel fractal approach in order to date obsidian. When the obsidian, this tool that is a blade used by prehistorians, were very useful in for everyday use, but we don't know when it was made. So this is another using fractal and complexity measures and machine learning. We have finally tried to date new dating method of obsidian and classify pottery, marble, mural paintings in art and archaeology. Fractal statistics overpainted. If we have overpainted, icon, how do we know there are two layers? Again, here we have made a very big project, and we have identified. We can identify if we analyze, with a multispectral imaging camera data by fractal analysis. We can say if there is one layer or two layers in an icon. This is another, new thing which has been published. So the use of complexity, 16 complexity indices, fractal, entropy, and complexity, identify the overpainted panel, and we have, and this is the last I finished, that if the upper layer of a painting is Egyptian blue or yellow cadmium or red cadmium, and the lower, there are 40 different colors. If we analyze such overpainted icons, only specific fractals can be applied per upper color to identify if it is overpainted or not. So if the Egyptian blue is upper, and many 40, in the lower color, then the cluster methods, allometric, gauge, septic, and subentropy is the ideal method to use if the upper color is Egyptian blue. If it is yellow cadmium, we use cluster methods, allometric, and Shannon. And if it is red cadmium, the upper, we use other fractal algorithms. So this is a very interesting development, of how to identify overpainted panels. As you can see, the STEM in the widest, range and spectrum of consideration can do many things in culture and art, and helps, to decipher the society, past societies, and bridges in practice, humanities with natural sciences, which makes a person very rounded, to live with harmony, to have comprehension, and to work towards understanding with other cultures, which after all promotes peace. Thank you.